All right. Hi, guys. This video is for Mrs. Vaughn's Algebra 1 class. I'm introducing section 1.3. I am going to go over the stuff in the book, some additional problems, and then give you guys the homework assignment that you have in your lesson plans. Hopefully this will record well. I'm at school, so the internet's a little spotty. We're just going to go over the homework when we come back on Tuesday. So give it your best try, and we'll see how we did then. All right, let me go ahead. We'll start with the vocabulary assignment. So let me share screen. Okay, so these shouldn't be too hard to find. All of this again is a review from pre-algebra. So in this case, we're talking about adding rational numbers. So we're also going to be talking about the properties of addition. So any equation or statement that is true for any value of the variable, that's why if it's a statement that we make where we use a or x in the place of a number, those are what we call our mathematical properties. So that's right there on page 15, right above the properties of addition. So that is G. And that would it. All right. What do we call the answer? This probably should be the answer to a addition problem, but that's what we call the sum. Hopefully y'all realize that. Sorry, that's a little ambiguous. Okay, another name for a mathematical property, we also call those identities or mathematical identities. So that's here, there it is, F. Cool, couldn't find it. Okay, so we're looking at for number 4, and we'll see that for 6, 7, and 8 too, is I'm actually putting the mathematical expression for each property instead of the word or the written description, because I feel like this makes a little bit more sense. So when we look at the addition problem, 3 plus 5 equals 5 plus 3, then hopefully you're seeing that this is the commutative property of addition. And you can think of it as the numbers in the problem are commuting back and forth. Like on each side of the equal sign, they're in a different place. So that's where the commutative, let me space E. These are so out of whack. I hate when they don't line up. Okay. Yeah, so commutative property is when they, the different numbers in a addition problem sort of move location, because you can switch them around. It doesn't really matter. Your answer will still be the same. Okay, so what do we call each number being added in an addition problem? That is called an add-in. And again, like an add-in is the same. The first one, the second one, the third one on are all called add-ins because you can interchange them. It's still an add-in no matter where it's placed in the list of numbers being added, which is very different from the subtraction problem. So again, that helps kind of remember that commutative property. Okay, so anytime we see a number or a variable and we are adding 0 to it, then that actually just means the solution is that variable or the value that's in the place of that variable. So that's just the additive identity property. Can't talk today. Because your solution is the same value as the number you're adding to 0. So they have the same identity, they have the same value. All right, so number 7, you can think of as the associative property of addition. So A, B, and C are all associated with each other because they're being added together. But it doesn't matter which one comes first, you're still going to end up with the same solution. So, that's an example of the associative property of addition. And 8, this is the inverse. Because we also, opposite numbers, we also call them additive inverses. That's another term for opposite number, because anytime you add a number to its opposite, the answer is always 0 because they cancel each other out. So they are inverses of each other. That's why that's the additive inverse property. Okay, so hopefully y'all got that. Let's move on to the actual lesson. Let me find my whiteboard. There we go. So you should see that. This section starts on page 13. I think all this, again, it's review. Like, I feel like none of this should be particularly new to you guys. Let's go ahead and move on to the top of page 14, where they're talking about adding positive and negative numbers. This was a struggle for the majority of the group, the majority of the time last year in pre-algebra. So I want to make sure we spend the time talking about it today. When we add positive and negative numbers, we need to be aware of the signs and what those signs mean. I am sure we'll talk about this later, but whenever you are adding a negative number, we understand, hopefully, that this is the definition of subtraction. So when you see subtraction, -1 minus 3, you should be able to recognize it means the same thing as -1 plus a -3. And if you can see it that way, then you can understand these steps for adding positive and negative numbers will work, even if it's written this way, like a subtraction problem. So you can reword it as -1 plus -3 if you need to help you remember your steps. Because when we see -1 plus -3, we need to first recognize that these two numbers have the same sign. Their sign is negative. So when we get to our answer, we know our answer is going to be negative. But what we want to do is we want to add the absolute values of both of these add-ins. So I'm just going to go ahead and put my absolute value symbols in here, save myself some space. And so then I see that this is 1, which is the absolute value of -1, plus 3, which is the absolute value of -3, and 1 plus 3 equals 4. But because I already have that negative sign and I know that my answer is going to be negative because I'm adding negative numbers, I got the right answer. All right, so don't forget to carry that negative sign. I like to do it first. That way I don't forget because it's easy for me to forget. Okay, all right, so let's look at if we have different signs. So if you have different signs, then you subtract the smaller absolute value from the larger absolute value and then give the difference or the solution the sign of the add-in with the sign of the larger absolute value. I know that's a lot of words that immediately made your eyes cross. All right, so let's just go ahead and look at this. Okay, so first off, we are changing our addition problem into a subtraction problem. So let's look at absolute value here. We have the absolute value of -3, which is 3, and we have the absolute value of 8, which is just 8. Now, let's go ahead again. Let's go ahead and get ready for our solution here. Which of those two numbers is a larger absolute value? Well, it's this guy, right? It's the 8. Therefore, and the 8 is in the original problem, the 8 is positive. Therefore, our answer is going to be positive. So we have a 3 and we have an 8. 8 is the larger of the two. So 8 minus 3 equals 5. And that is our answer, +5. Please, when you write your answers, don't leave the positive sign there. Not having a positive sign in front of a number means that it's a positive number. Oh, wait a minute. I said that backwards. Not having a negative sign in front of a number means it's positive. Okay. So let's look at 4 plus 10. So 4 plus -10. So again, if you look at the absolute value of these two, you can see that the absolute value of 4 is 4 and the absolute value of -10 is 10. So this guy is the larger absolute value. I'm just going to use a symbol here. Therefore, our answer is going to be what? It's going to be negative. All right, so 10 minus 4 is 6, and we carry that to our answer. So our answer is -6. Okay, I'm hoping that makes sense to you guys. We'll see some more practice here in a minute. Okay, let's look at the properties of addition. These need to be on note cards. They do need to be on their own individual note cards with the name on one side of a note card and the definition and example on the other side. Okay, or just take really, really neat notes. So commutative property of addition. A plus B equals B plus A, or 3 plus 5 equals 5 plus 3. Good deal. Number 2, the associative property of addition, A plus B, then plus C equals A plus B plus C. So if you have 2 plus 9, which is 11, 11 plus 4 is 15. Or if you have 9 plus 4, which you have to do first by order of operation, you have 13. 13 plus 2 is 15. Therefore, 15 equals 15. Yes, we're good. All right, additive identity property means that any number added to 0 equals that number. So 3 plus 0 equals 0 plus 3. That's the commutative property of this. But it also means it equals 3 because anything added to 0 equals the value of that number. Number 4, additive inverse property. Any number plus its opposite will equal 0. So 3 plus negative 3. This is the same thing as 3 minus 3. And we have a 0. Okay. Okay, let's look at an example of these properties. I'm just doing the first one here. So what you want to do, because first off, we're going to use the commutative property. Can't write straight, of addition by combining all of our negative numbers together. So we have, and then all of our, oh, that's my positive here. Let's do this. Okay, so commutative property. I'm actually going to start with a positive because that makes me feel better inside. 5 plus 4 plus, I'm just going to do this guy here, negative 1 plus negative 3 plus negative 7 plus negative 6. Okay. And so that way I can do all of these first. And that leaves me, and then I'll do these guys as well. So 5 plus 4 is 9, 9 plus, and then what I have inside here is really a negative 1 plus 3, which is 4, 4 plus 7 is 11, 11 plus 6 is 17. So I have 9 plus negative 17. All right, and then I use my rules for adding unlike signs or different signs. And so let me put this over here. I have 9 plus a negative 17. Let's get my absolute values. Absolute value of 9 is 9. Absolute, I'm not going to put that there. Absolute value of negative 17 is 17. So this guy's the, why did I do that? This guy's the larger, which means my answer is going to be negative. 17 minus 9 is 8. So I carry that to my answer bar, and my answer is negative 8. Okay. All right, so let's work on some additional problems. These are not in your books. These are going to need to go in your notes, so you have some good examples when you work on that homework. All right, so again, 3 plus a negative 4. Let's get our absolute value of these two. And we see the absolute value of 3 is 3. The absolute value of negative 4 is 4. And hopefully you've already seen as well that we are adding unlike signs or different signs. So we're going to have to subtract here. But we also know that our answer is going to be negative. So 4 minus 3 gives us 1. So carry that down to my answer bar, and my answer is negative 1. So let's look at 2. So 2, we have like signs. So we know that our answer is going to be negative. So let's go ahead and get the absolute value of these two. And we end up with 7 plus 8. And 7 plus 8 equals 15. So carry that to your answer. It is negative 15. All right, 3, we're adding unlike signs here. So let's get our absolute value. We have 4 and we have 15. Now 15 is already positive, so we know that our answer is going to be positive. So let's just subtract our negative number. And this gives us 11, which is our solution. That's our sum. Okay, bigger numbers, but same concept. Also, let's look at number 4 really quick. So you can tell from here that we are adding different signs, but we know that our larger absolute value is our positive number. So let's just go ahead and turn this into a subtraction problem. 137 minus 64. No need to get too complicated. As long as you recognize that's just the basic subtraction and your solution is going to be positive. So 7 minus 4 is 3. 13 take away 6 is 7. So our answer is a positive 73. All right, so let's look at number 5. Number 5, we do have like signs here. So they are both negative. Therefore, our solution is going to be negative. So let's just add their absolute values and bring that down to our solution bar. So we have 247 plus 139. That gives us, that's 16, carry my 1, 4, 5, 6, 7, 8, 2, 3. So negative 386 is our answer. Okay. Oh, fractions, lovely fractions. That's okay. They have the same denominator, so no worries. What we want to look here then is I would go ahead and take that negative and put it with your numerator. And all right, and so we see now that we are adding unlike signs. So let's just look at our numerator here. We have the absolute value of negative 8 is 8. The absolute value of 13 is 13. The positive number in our problem is our larger absolute value. So we know that our answer is going to be positive. Just going to bring that down here. And so 13 minus 8 gives us, what, 5? All right, so our solution is negative 5/9. Why did I say negative? Sorry, I already determined that our greater absolute value is positive, but there I went throwing negatives around. Positive 5/9. All right, sorry. Let's look at number 7. So we have the same denominator, so we're good there. We do have we are adding like signs here. They're both negative. So in this case, our answer is going to be negative. So let's just look at the absolute value. So the absolute value of negative 2 is 2. Absolute value of negative 5 is 5. So that gives us 7. So our solution is negative 7/7, but we can reduce that to negative 1. Okay. All right, number 8. Number 8, we have 2 completely different denominators. So first, excuse me, first we need to get common denominator. So I think these are each other's common denominator. So I'm just going to do 2 times 13 and 13 times 2. So that gives me, do it to your numerator as well. All right, so 2 times 13 is 26, right? Yes. So we have 26, and then 3 times 13 is 39, plus a negative 6 times 2 is 12, and this is 26 as well. All right, so again, look at these two. Which one is larger? A 39 is significantly, absolute value of 39 is significantly larger than the absolute value of negative 12. I'm just going to move that up there. And so when we look at that, we know that it's just really just 39 minus 12. So let's figure out our numerator. We do 39 minus 12, then we end up with 27. All right, so our solution is a positive 27/26, or 1 1/26. I'll be honest, I prefer mixed numbers to improper fractions, but I will take both. Okay. Let's look at some, my box is too big. Let's look at some decimals. Decimals get a little bit tricky when you're working with negative and positive numbers, so definitely follow your rules with these. Number 9 is pretty easy. We're looking at 2 completely positive numbers. So and we're adding. So let's line up our decimal points. To add these properly, we have 2 and then 386 plus 5 and 0.29. You can add a 0 there if you want to. But we're adding. So that's 6. 8 plus 9 is 17. Carry my 1. This becomes a 6. 5, 6, 7. So our solution is 7.676. All right, and now a little more complicated one. We've got a negative and a positive, so let's look at our absolute values here. The negative number has an absolute value of 18.72. And the positive number has an absolute value of 3.389. So our negative number is by far the larger. Therefore, I'll give myself some room here. Our answer is going to be negative. Okay, so let's go ahead and subtract our smaller number from our larger. 0 there. 0 we have to borrow, so this becomes a 1. This becomes a 10. 10 take away 9 is 1. And then that's not going to work either. So let's 6, and this becomes 11. 11 take away 8 is 3. 6 take away 3 is 3. 8, and then the rest is good, right? And then this is 18. So our solution is negative, or our sum is negative 18.331. Okay. I hope that made sense for everybody. Anything else? Let's talk commutative properties. I think we're good. Go ahead and give your homework a try. You've got that on your lesson sheet. Let me see. It's on page 16, 1 through 39, odd only. So homework, page 16, 1 through, what did I say? 1 through 39. Okay, that's what I thought. 1 through 39, odd numbers only. So 1, 3, 5, 7, 9, 11, etc. All right, and that's all I've got. So thanks so much, you guys. Hopefully we will be back together next week. Please don't make me make any more videos. So I'll see you on Tuesday. Have a good weekend.